access and control, but we covered so much of it in that good training that we had out there that we basically all know what happens when it gets to the tank. I covered a little bit of history of the tanks in here. As far as we knew, there are no existing as-built on that tank anywhere to be found. We checked warehouses all over the country and couldn't find anything. But they were built in '52. It's a 1-inch steel plate, butt welded construction from the bottom up to a 1/4 inch to the top. We replaced the entire roof from 3/16 to 1/4 inch plate. The added weight on there, we had to install a rafter hat, what we call a halo, inside of the, there's a picture on page 3 of that rafter hat system. And basically it's a dollar plate support system with the rafters going across the top of the girders. So we just added a 48-inch roll channel rafter hat to help support that rafter system inside at the center. The outside panels were a pretty big concern because they were a transite type panel. They have 7% chrysotile in them, which basically means you probably got more asbestos in your house than what actually comes off those outside panels. Unless you're grinding them, drilling them, or anything else, you know, a dust mask to replace them or something like that. But if you're drilling or sawing them, then proper PPE, tieback, respirator, and stuff like that. It is a non-hazardous disposal on those panels. Let's see, they were replaced with a 4x8 fiberglass sheet that's commercial grade exterior from Harrington Industry right here in Chino. So if you ever have to replace them, you can go right to that manufacturer. We supply that in the O&Ms for any replacement panels. And they probably will crack because those tanks flex, as you well know. So we installed a drip rail, a 2x3/4 rolled angle drip rail around the edge. What that does is protect the water from going in against the tank wall in between the outer panel. There's a mineral insulation in between there, so that drip edge basically diverts water from the top and to the outside, so it runs to the outside of the panel. It doesn't destroy the inside. I think you can see it. They got a picture of the panel. Problems that we had out there. That Evermore is just a basic high commercial grade acrylic flat paint. You pick up at Home Depot to cover any repairs that you may do out there. Hard color to match because we had green and orange and brown and everything else. So the engineer chose the closest one. The next one is just a picture of a 6-inch insulation foam that we took off of the roof there to get to the roof plates and replace that. To access the tank, we had to cut a door in it so we could get our equipment in. We did all the coating and abrasive blasting and structural repair off of boom lifts that we traversed through the door. Welded it back together with a full X-ray weld, and that's how we accessed the tank. The internal piping is, we didn't touch too much on that, but it's a 36-inch, 1/4 inch wall, epoxy line. It runs from the penetration of that 36-inch valve and goes horizontally across the tank about 62 feet. And it hits a double leak check valve inside of there, backs up against that. Once the water backs up against that, it pressurizes to the inlet pipe, which is right above the tank penetration. And it goes up, feeds that through another check valve, and feeds out that way and then fills the tank. So when you reverse the flow, it's just a gravity flow that comes out through the bottom of the horizontal piping, goes back through that check valve, and then releases back into the system. A real simple system, no maintenance on it at all. So,
Can I show the diagram?
yep. So it's pretty self-explanatory on how it works. Let's see, what else can I touch on here? The inlet and outlet flow on the outside, if you got any questions on that, I think we're all pretty well versed on that. The only Zerk fitting on that system is the 6-inch plug valve. It's a 6-inch valve that goes on the outside of the tank. Should have looked at it when we were out there, but it's just a little gate valve. We open it up. It drops in a 6-inch over the top of a sump. It's a 1 foot by 2 foot sump in the bottom of the tank. And it's just a depression in the bottom of the tank. It elbows down over the top of that. So once that flow can't go lower than the 1350, and you need to drain the rest of the tank to get into your manways, you just plug in. It's got a male coupling, cam lock coupling on the out of it. So you can cam lock the water truck, cam lock anything you want. Open up the gate valve and drain it the rest of the way down below your 24-inch manways. So you can open up your manways. The manways are just a blind flange manway. Nothing special. We put them on, hand tighten them, knock them twice, and go around it 3 times, knock it twice. And it's tight. You're usually getting 750 to 1250 now. You do it like that. If there's any leaks on it, usually indicates maybe they didn't go around enough, tightening it around, or there might be some kind of grime or something in the gasket itself. Any questions so far? It's all pretty basic stuff that you guys work with all the time, so my part's easy. Got anything else you want me to touch on?
Flow process.
All right, the inlet flow recycled water is pumped from the RP4 plant to the reservoirs through an existing 48-inch. And the 48-inch is reduced to a 36 at station 5 plus 71.82 near the reservoir, where it stubs out into 36 that we saw where it comes out of the ground. And it continues at that point, it Y's at tank 1 and then continues straight into tank 2 on the same system. Continues up through the 90-degree elbow above the ground, passes through the 36-inch butterfly valve where you can isolate the pipe there, through the mag flow meter into, let's see, well, obviously we went through the flow meter information, and it's also connected to your system over here through fiber optics. It reduces down to a 24-inch butterfly valve and into the altitude valve that we have out there. Then it increases back to a 36-inch and passes through the spool at the tank wall. The system was originally designed with the 36-inch butterfly valve just past the expansion coupling. We changed that around so we could actually, if there was a problem with that pipeline, you could isolate that tank at that 36-inch butterfly. Because if you had a problem in between 36 and your tank wall, then you could have problems and you could lose your whole tank. So that's why we isolated it. Replace the 36-inch location at the tank wall itself. The mechanical, or excuse me, the flex coupling that's installed out there, we didn't touch on too much, but that's got a 15-degree rotation in any direction for seismic conditions. So that's made to move in any kind of shear movement. So
But
it's
that one has actually been installed.
It's installed at its fully extended position right now. So it has no movement in or has no movement out.
Has no movement
It
out.
has shear movement.
Has shear and in.
That's the heaviest piece out there. And then to disassemble, the disassembly locations are between the mag meter and the altitude valve at the dresser couplings. disassemble it there. It's just a slip joint. You can take that whole section of pipe and you can start taking sections out as you need to replace it. So, if you need to replace it. Outlet flow is basically the opposite. It's just by hydrostatic pressure. So once the tank's full, valve closes, opens up the butterflies on the inside to reverse flow, and then it just hydrostatic pressure out. Pretty well designed.
Just a quick question on that, on the elevations. I've been calling this 1158 zone, which I guess is an elevation. According to this though, the altitude valve shuts when it gets to 1150. So that's actually the top. It's not really 1158, it's 1150.
Yes.
Yes.
I'm not familiar, is that kind of the 1270, 1299 issue? Is that 1158 was done on paper and the reservoirs give you 1150 and it was just an acceptable compromise, similar to on paper when it was all on the tabletop, everything was called 1270, but when they found an available reservoir that happened to be a 1299, then that was an acceptable compromise just to take advantage for cost savings. Is that same question here? Why we can't get 1158 at our full tank level, or is there?
The 1158 is actually the wall and the roof connection of the elevation that we had. We had an elevation of 110, 1110 as a floor, so we set everything out there.
Yeah.
Because like I think it mentions that there's an overflow pipe at 1151.5.
Mm-hmm.
So we're not going any higher than that.
No, the water right now it's shut. We have it set at 48 right now, the altitude valve, just for filling purposes, and then we can adjust it a little bit as we fill it up. But they want it set at 1150, which is 1.5 feet below the overflow.
On the overflow of 1151.5, what is that as far as a rough idea? Don't need close numbers, but as far as freeboard on the tank when you're in an overflow condition, is it 1 foot or 5 foot, or is it right near the?
I don't know. I'd have to find.
It said that at 3.
Pardon?
It's 3 foot. I thought
3 foot of freeboard.
That's what I recall.
Yeah.
I think it was 3 foot. They said that 3 foot.
Once it hits the crest line of the overflow pipe, it'll go down that overflow pipe. It's also a 36-inch, and it's got just a hinged gate valve or a flap gate on the outside of that. So pressure just pushes it open into a dissipator, riprap dissipator, just for erosion control. And I think we're actually, when we fill the tank, we're actually going to go to the crest line of the overflow and then bring it back down.
That 36-inch overflow, that's, if I remember right, that's interior, and then the actual flapper
Is on the exterior.
I see that.
We're going to crank that nut down and actually let it run its process and then crank it back.
Do we have any type of drain system that's actually by these tanks?
No.
Nope.
It's all containment.
We were pleasantly surprised when they went in there with the pipeline to find out that there wasn't a bunch of leaching from the fuel oil from before. You know, when we opened that thing up, we really expected to see some, back in the 50s and stuff. It was like, whoosh, they just dumped it on the ground.
Yeah.
So that was a pleasant surprise when that got opened up.
You didn't touch on the floor repair.
Oh, thank you. In tank 2, the west side tank, we did 4,800 square foot of overlay floor repair in there. We got that off. I don't know if you've ever seen the DJA report on the spec book, but they went in and sonically tested the floor, found underside soil pitting in approximately 352 locations that gave that bottom about a 5.4 year lifespan without covering it up. So we went in with 1/4-inch plate, welded over the top of it, and it'll give us another, with that in those areas, we're over 25 years. Tank 1 had no repairs done to it. We did find a little bit of corrosion around the edge in 2 spots. We did a 4x4 repair on the southeast side. That lifespan on that floor right now is at 19.7 years by the report, so it's some decent life out of it. So the cathodic system is set up to protect all that. So. Coating system we used on the inside was a 3-part coating system, averaging about 19 to 20 mils of epoxy lime coating. Anything else? I'm so good at this.
On that epoxy line coating, is there any, before filling it, is there any ventilation requirements or recommendation?
It says that the roof vent on top is a 48-inch roof vent made for the tank size itself, which ventilates it sufficiently. We disinfected it when we finished coating it, so it's disinfected and flushed and ready to go. Ventilation should be fine.
Is the 48-inch vent you mentioned, is that just passive, or is it active? Is it motor-driven type
No,
of size?
it's
Just passive.
passive. So we don't anticipate any problems with the tank structure itself. It all seemed to be in pretty good shape. We had a little bit of corrosion on the rafters and stuff that came off really good with the garnet blasting that we did in there and covered up everything. So.
So just wanted inspection format for all the coatings. Went over it on the tops of the rafters. We're also holiday tested, and we found a few areas and they recoated them. So it looks like we're above mill thickness pretty much on the whole interior in spec. So all those reports are going to be inserted with the
And then we seamed the entire roof wall connection and all the rafters where it meets the roof plates with the Sikaflex line. So it's all completely sealed up.
Any questions?
I think the plug valve, like I said, it's only Zerk. Might go out there and grease it once a year or something. I don't know if you'll ever get to the point of actually having to use it. But